class. Welcome to the next lecture of production and operational management. In today's lecture we are going to discuss about project management, so which is your topic unit 5. So first of all, let us see what is a project, how project management is being done in your production. So generally what is a project is nothing but any activity which you are going to be doing. So for doing any project, for example, either it is your academic project, or you have got a project from your outsourcing industry, so anything so which involves some planning, scheduling, controlling, so it requires some amount of material, and it requires some amount of time also. So these things which involve some amount of inputs and outputs, basing on which the completion of task is done, that is called as a project. The project may be extremely large or complex, such as construction of house, highways, shopping, etc., whatever it may be. So everything is a project. Okay, it is required that manager must have a dynamic planning. So when a task, a particular project is given to some person, so he should be having a proper planning, scheduling, so that he can give the best possible results as early as possible, and it should have least cost involvement, material involvement, men involvement. So this is what, if you want to construct a house, so what you will try to do, you will try to build a good house at a least price. So whatever easiest way, or what is the amount you can reduce, you try to reduce it. So in this we have the project management is being, or evaluating is done by two techniques. The project measurement is being done by two techniques. One is PERT, which is nothing but project evaluation and review technique. PERT, this is one of the most important questions in your 5th unit. Project evaluation and review technique, PERT. And next is CPM, critical path method. These two methods are there which we generally use. So in critical path method, this method is generally used for the techniques which have already the same procedure of doing. Okay, whole process is same, but where we apply is different. So in critical path method, we just use the technique where the system is already known, where the risks are already known. So it will not be applied for a new projects. It will be always used for the plans or the things project which is already been done. So it is generally used for a repetitive type of work. Okay. In PERT, what we generally do is this technique was generally used by a US company or US Navy for the first time in 1950s. In this, where we use this project evaluation technique, where we don't know what are the various types of risks we come across. So the risks may be a positive type of risk, or it may be a negative type of risk. So in considering all those things, we do a project management in PERT analysis. But whereas in CPM, we know all the errors, all the things we know, but we try to optimize the the path, so that we get the best results out of it. Okay, so though the PERT and CPM techniques are similar in terms of concept, the basic difference is PERT is used for the analysis of projects, scheduling problems. CPM has a single time estimation, means once it has been estimated, it will be keep on repeated time. But whereas PERT has 3 times the estimation has to be done, because it is completely based upon the probabilities. The probability is nothing but it may even pass, it may fail, so it may give a positive result, negative result, so both should be included. Okay, so in project management generally we have 3 phases. One is planning phase, scheduling phase, and controlling phase. Before starting of any project, what we do, even as an academician, even as a student, when you allot a project to you, so first you will understand what is the project. Okay, what is your main aim behind doing this project. So after identifying all these things, what you will do, how to start. So from the initial, from the scratch. So from the scratch to the product, how you have to start, that you will plan accordingly. Okay, next is scheduling. When you have done planning on the paper, then next thing is schedule. So if you want to complete your the exam preparation, you will schedule. So this is the date of your examination, this day I will study this subject. So you will be scheduling few things, how your preparation has to be carried out. Similarly, while doing a project management based upon the time estimation, the start and finish times of each activities are worked out by applying forward or backward pass techniques. So that we will discuss what is a forward pass or what is a backward pass technique. Next is controlling. So after doing planning and scheduling, you have scheduled that today I will complete my HTR production and operational subject. But because of some relatives coming to your home, you may not stick to the plan, or you may whatever the plan you have done, you have planned to complete the 5 units, but it was not possible for you because of some reasons. So you will try to control yourself. So what are the external factors because of which your planning and scheduling are getting delayed, are getting what we say changing? So you try to control them, you try to correct them and bring them back to the as per plan and scheduling. Okay, so let us see what are the first things, components which we generally use in PERT CPM networks. Okay, the PERT and CPM network completely uses basically two type of things. One is activity, another is event. Okay, so event is nothing but the start. Event is nothing but the start and end of any activity. For example, you are doing some work. So from where you started work, where you have ended work, that work is nothing but the event. Starting is event, end is event. So from starting your subject to ending of your subject, it is called as event. But whereas the activity, how you are carrying out, so the activity represents the action and consumption of resources. So while doing some work, you need some kind of resources, either it may be time, money, energy. So to complete some amount of project, that is called as activity. But whereas event, it is nothing but the what is the portion you have completed, what portion you are going to complete. So that start and initial, it does not require any kind of resources. It is just what we say, the node or the point which indicates you that your project has completed till this end. So information about the activity. Okay, so merging and burst events. Merging events and burst events are nothing but if an event is nothing but that is your completion of a task or starting of task. So the starting of task maybe have three inputs. So basing on which for example, if you are going to start for the college, so there are n number of factors basing on which your starting depends. That is by the time, the completion of your breakfast or catching a bus. So n number of activities are involved in your event. So if all these together, until unless they complete, you cannot start. So that type of event is called as merging event, because of n number of events, more than 2 events if they are coming together, because of which you cannot start, without which you cannot start. That type of activity is called as merge activity, merge event or merge event. Okay, but whereas burst event is nothing but because of that one work, your n number of works are going to complete. If you start from the if you start on time from the home, there are n number of possibilities that you may get the bus easily, you may reach the college on time, the traffic may be less. So because of taking one step, there will be n number of possibilities. So if you don't do that work, there will be no further work will be there for you. So that kind of activities. So generally we even call this as converging, and this is called as diverging events. Okay, next is preceding and succeeding activities. Preceding and succeeding activities is nothing but step by step procedure. So preceding means past, succeeding means next. Let us take an example. Okay, these are called as network diagrams, which we will see how to draw this network diagram. So here I am saying J precedes A, or J precedes I means J is before I. Similarly, C precedes A. We can take in terms of activities, or we can take in terms of nodes also. Okay, so A precedes C, we can say, because A is before the C. Next is C succeeds A is nothing but after completion of A, C comes into picture. Succeeds means next activity, precedes means past activity. Okay, activity A, B precedes activity C and D. Okay, obviously these two are before that of A, B. Okay, that's what they are giving example. Next is dummy activities. So this activities does not consume any kind of work, any type of resources. But why we go for dummy activities? Nothing but to close the loop, or to have the logical network circuit. So they does not have any influence. For example, in this diagram you can see that A is related to B, B is, and again this if you take 1 event, 2 event, 3 and 4. So third event is related to 3 and 4, but whereas 3 and 4 are not related to one another, because of which your network seems to be open. So for completing the network, I am trying to use a dummy network, because of which the complete circuit is going to be closed. So that type of activity is nothing but called as dummy activity. So you can see the definition: imaginary activity which does not consume any resources and time. It does not involve any resource, and it does not consume any kind of time. So is called as dummy activity. Dummy activities are simply used to represent the connection between the events in order to maintain the logic in the network. Okay. Next, so there are some few errors while we are drawing. So first of all, let us understand why we are going to this. All things is nothing but for every project we will be having a sequence of steps: planning, first step, second step, third step. So there will be n number of steps, n number of ways of doing a project. Okay. Out of these projects, out of these ways, which path or which way of doing the project is the best way, that we are going to identify in both the techniques, either it is a CPM or PERT, both we are doing. So that is nothing but critical path method. The path which you are going to what we propose, that will be a most beneficial path for the conduction of the project, for the doing of the project. Okay. Okay, the two activities. So what are the generally errors which we generally students do in drawing the networks, especially are? So first thing is, two networks should not start at the same point and should not end at the same, means these are same events. So both events are having two number of paths. So first path is this, second. So it should never happen. It should never happen. If there are two events which are starting from same point and which are of same magnitude, then you should use this kind of thing. So first 1, 3, instead of using 3, you should give another number. Then by using the dummy activity, you try to connect them. But never you should use same between the two events. More than one path should not be used. Between the same events, more than one path should not be used. One arrow mark should not be used. Next is, looping errors may be formed. This looping errors is nothing but the directional faults. That is nothing but, here if you see what is looping error here happening is, the direction from here to here, from here to here, again it should not come from here to here. It should go from either 1 to 3 or from 3 to other parts. You should not be a closed, like your vectors, it is not a closed vector. You should not do this kind of mistakes. Okay. Next, in a network there should be only one start event and one end event, means same, first and third are same. So it should not have the same start and it should not have the same end. Okay. The next point is, the direction should be properly mentioned, that the wrong direction should not be given. Another thing in this you have to remember is, while drawing the networks, the network line should not cross one another. The network line should not cross one another. It is not recommendable to cross the network lines. Okay. You can see here what are the rules in construction of network. No single activity can be represented more than one in a network. The length of arrow has no significance. You can draw bigger one, smaller one. It does not have any influence in the diagram. So the event numbered 1 is the start event, and the event with the highest number is the end event. For example, if you are starting from the project, for doing a project you require 10 steps. So first step is your initial step, 10th step will be considered as your end. Okay. In assigning number to the event, there should not be any duplications of event numbers in any network. Duplication means same number should not be used anywhere in the network. The dummy activities must be used only if it is necessary to reduce the complexity of the network. For example, if it is keeping open at some points, you may use, but never, always you should not go for dummy activities. Wherever necessary, wherever required, you should try to use. Why we are using dummy activities is, one thing is to close the circuit, second is to reduce the complexity of the problem. Okay. So the network should have only one start event and one end event. Okay, like this. So this is also these are all events. So initially if you take activity B precedes activity A, activity C precedes activity B. Okay. So this is a network. Similarly here B precedes A and B and C both precedes A. Okay. After the completion in this, another thing you have to remember is, until unless the activity A is completed, B and C will not start. Activity B and C will not start. Once activity A is completed, both B and C will start immediately. Both will start immediately. Here in this, if you understand, until unless A and B are completed, C will not start. If A is completed, still B is not completed, then also the event will not be started. Both should be completed. Here one completed means both will be starting at a time. Here both completed, even if there is a time lag or time delay, until if both are completed, then only this will start. Okay. Clear? So see this last network where they have given A is connected to B, B is connected to C. Similarly, B is connected to this event, this connected to D event. But whereas here these two networks are these two events are not having any kind of connection. So you can use a dummy activity. So activity C must start only after the completion of activity A and B. That's why we are drawing a dummy activity. Means until unless these two are completed, either it is because of A or B, even though they are not related, but because of this dummy activity, we will write that until unless A and B are completed, we cannot start, C will not be starting. But whereas once the completion of B is there, D can start, but activity D can start once the activity B is completed. It is not related to A now. If the arrow mark was towards B, this event, if the arrow mark was, let me show you, if the arrow mark was like this towards this event, okay, if the arrow mark was like this towards this event, then you should have, after the completion of A and B only D will start. After completion of A and D will only this will start. But whereas because of the arrow mark above, only after the completion of A and B, C will start. But whereas once the B is completed, C will automatically start. Next, what is this Fulkerson rule is nothing but, so this procedure generally says this all things which we have studied. So until unless one event is completed, you should not start the event, the numbering should be given. These are nothing but the Fulkerson's rule. Okay. So the number that starts our initial event as 1. From the event 1, strike off all the outgoings, means all the outgoings. For example, this is my first event. So after that, if there are 2 events, you should take 2 events. If it is 1 event, you should take. How many number of events are there? That many number of events should be started off from these activities. This would have made 1 or more events as initial event. Even which do not have incoming activities, the number that event as 2, which does not have any incoming activities, we should give it as 2. Repeat step 2 for the event 2, next event 3, event 4. For example, we have drawn here, we are doing, so this is 1 means this is 2, this is 3. Similarly 4, 5, 6, you have to give that numbering and you have to continue the procedure. Let us take a network diagram, how to construct the network diagram for this event. So what is the project we are going to do here is construction of a house. So let us see what is the plan actually. So actually the plan is preparing of house plan. Yes, so that activity I am taking as initial activity A, which starts from 1 to 2, that is nothing but first step to second step. Next is construct the house. Once plan is ready, what you will do, you will construct the house. Once house is constructed, what you will do, you will try to fix the doors and walls. After fixing the doors and walls, you will try to wire the house. Wiring will be given. After wiring, you will try to paint. After painting, you will do polishing to the doors and windows. Your home will be ready to occupy. Okay. So what are the activities? These are the activities. What are the nodes they have given here? Start event and end event. So for A activity, start is 1, end is 2. For B activity, start is 2, end is 3. For C activity, start is 3, end is 4. Similarly for D activity, 3 and 5. So E activity 4, 6, 5, F activity 5, 6. So in this they have given, and sometimes they will not give you this. They will just give you these values. Okay. They will say that initially A is there, B precedes A, B precedes C, then B precedes D, means B is an input for both C and D. B is input for both C and D. Next, C precedes E. C precedes E means E starts after the completion of C event. Okay, C activity. Next, F starts only after the completion of D. If D is not completed, wiring of house is not completed, you cannot go to polishing. Okay, because even if your house is not painted, you can polish your doors. You can polish outside, you can bring your doors and you can fix. So they are not dependent upon one another. Clear? So let us take. So I am trying to keep the nodes 1 to 2, 2 to 3, from 3 again 3 to 4, 3 to 5. Okay, 1 to 2, 2 to 3, 3 to 4, 3 to 5. Because here 3 is repeating 2 times. 3 is having 2 activities. One is C activity, another is D activity. From D again you will get an activity of 3 to 5. From E activity, sorry, from C activity you are going to see this from 4 to 6, 4 to 6, next C 5 to 6. You have completed this. Once you have completed your activity, this activity generally from 1 to 2, how many days you are taking, the time consumption has been given here. So they say that for a preparing of house plan it requires 4 days minimum for them. So 4 days you have written. Next, for completion of construction of house you require 58 days. You require 58 days. Okay. After that, for completion of this fixing of doors you require 2 days. Every data is given, you are just inserting the data there. Okay. So in this way we have to draw the network. Now you can ask me, sir, can we use a dummy here? So if a dummy is here, even though it will not indicate any time consumption or resources, but it says that with the completion of this task and this task together, then only this task will start. But whereas wiring and this fixing of doors will not depend upon one another, neither the paint of house does not depend upon the wiring of house and fixation of doors. Okay. So the painting you can do of meanwhile also, so it does not depend completely on one another. So no need of using a dummy activity. If you feel that these two are important, then you can draw an dummy activity. Then it will indicate that only after the completion of 5th task and 4th task, then only the task E will start. Task E will start. That is nothing but the event E will start. So the network diagram in the figure 8.11 shows the procedure relationship between the activities. Activity A, preparation of house, has event 1 and 2 as ending. Activity B, the construction of house, begins at the end of 2 and 3. The activity B cannot start until the activity A has been completed. Activity C and D cannot begin until the completion of B has been completed, but they can be performed simultaneously. Means once B has started, they will automatically start. Similarly, activity E and F can only start after the completion of C and D respectively. Both E and F finish at the event end 6. Both will end at event 6. So considering the project given in the table, construct the network diagram. Okay, we have constructed the network diagram. Next is table for 8.2, sequence of activities for a building. Sequence of activities, what are the sequences we generally follow. Okay, this is the example 2. How we are going to draw this, let us see. So here they are, instead of giving the time period, instead of giving start and end, they have just given the activities. So basing on these activities, you can see that first they are purchasing the land, next is preparation of building. So they are having 2 activities here. They are having 2 activities. So these are the 2 activities. Okay, purchasing, next is this one. Okay, just a second. Okay. Next is C, leveling of clean the land. Next is register and get approval. So registration and approval will depend upon purchasing of land, preparation of building plan. After completion of these 2 only, you can go for registration approval. Next is construction of building depends upon the level and clean land. Next, paint the building depends upon the registration and getting approval. Okay, and building also. So here what we have done, correct representation of it. You can see that. So A and B, because people will start seeing this, so the D will start after the completion of A and B. D will proceed A and B. So what they will do is keep this as a D, and they will see that A and B are coming together. From A it will, so this is a wrong type of procedure. Similarly here also it is a wrong type of procedure. So means what we have to explain, what we are explaining here is the event node 1, from the node 1 itself we have 2 activities starting. We are having 2 activities starting at a time. So one is purchase, then is preparation of building plan. So when you know that I want to construct a home, as soon as you purchase the land, you know you will not wait for the the plan of the house and everything. So immediately we will do. So these 2 may be independent activities, but they start from the same time. Okay, same activity or same event. So once the completion of A, you can see in the table, so once the completion of A, what will start? Once you purchase the land, obviously you will try to clean and level the land. Okay. Next, once you complete the leveling of land, you will go for construction of your house. So this is construction of your house. Okay. Next, come to let us B point. So when the preparation of building plan is done, you go for registration. You go for registration. So the registration we are going. So here this event is also depending upon B as well as A. So we know that if this is also depending upon this, if there is no direct network between them, we will join them by using a dummy activity. So you may ask, sir, you can directly use this, no sir. So here what is happening? This error is coming. So from the same point we are getting two start and end points, which is a wrong procedure. Already we have discussed that. So we should not do that type of mistakes. So because of that reason, what we have done, we have shown A separately. Then what we have done is we by using a dummy activity, we are suggesting that after the completion of A and B only, the D activity will start. So this dummy activity, even though it does not consume any time, it says that after the completion of A and B only, D will start. So what is your D? Registration and approval. Okay. Next is preceding to D is nothing but F activity. What is your F activity? Painting the building. Painting the building. Once the construction is completed, obviously you go for painting of building. Once your painting is done and once your construction of the building is completed, so your whole house will be completed. Your whole house will be completed. Okay. So next is construct a network. So this initial was 1-to-1. So it is having one activity with one tail and head. But whereas here starting point is one for two activities. One node is used for two activities. Here one node we are having three outputs. So 1, 2, 3, three outputs are coming. That is nothing but three events are starting immediately from the first as soon as you have taken the plan. So construct the project whose activities and their preceding relationships are given in the table 8.3. They have given A, B, C. So there are no time, nothing is given, means both start from the same situation or same position. Next, from D precedes A, E precedes B, F precedes B, G precedes C, H precedes D, I precedes E, J precedes H I, and K precedes F J. Okay. So in this way they have given. So first of all, these three starts with the same point. So A, B, C, all three are starting. I am giving the numbers 2, 3 and 4. 2, 3 and 4. Done. So once you are done with this, see that so A precedes what? D. A precedes D. So once the completion of A is done, what should start? D will start. Okay. D started. Now after the completion of D to the node which is starting, let us see, H is starting. So I am starting H here. So once it is completed, you are getting to some end node. Okay. Let us see the B section now. So from B, two activities are going to start, E and F. So E activity I am doing. So two activities I have joined. Next, from C we are getting a G activity. From C we are taking a G activity. Okay. Next is H is a preceder of D, that is completed, or I is preceder of E, I is preceder of E. So yes, so once I is for starting of I, you should proceed B and E. You should proceed B and E. After completion of B activity and after completion of E activity, then only your I activity will start. Next, similarly here they might have written you H comma I, means these two should precede the value of this node, that is nothing but J, that is nothing but J. Now J precedes H and I and K precedes F and G. What they are saying, K precedes F and G, but F is starting from B itself. F is starting from B itself. So that F and this G will come together. You have to see all the, then only you have to draw. First you can draw roughly and then you can make it fair. Okay. In this way you have to draw the network analysis. You just go through this PPT, you will get much easier when you are preparing for exam. This is one of the easiest topics where you can easily score, until unless there are tough problems or more number of theory part is asked here. So the critical path analysis, what is this critical path analysis? Nothing but we have to select the longest path, okay, longest path among the whole network, okay. Since all activities must be completed to complete the entire project, the length of the critical path is also the shortest time available. The length should be longest, but whereas the time consumption should be shortest time allowable for completion of the project. Thus, if the project is to be completed in shortest time, all activities on the critical path must be started as soon as possible. These activities are called as critical activities. So, which starts as early as possible. Once one within a short period of time, that type of activities is called as critical activities. If the project has to be completed ahead of the schedule means your scheduling of the project is done on 10th of September, but you are completing before September itself, then it is nothing but called as ahead of the schedule. Then the time required for the least one of the critical activity must be reduced. That is the least time, whichever is having a less time, that should be reduced, okay. Further, any delay in completing the critical activities will increase the project duration. For example, your schedule has been done on 10th of September. If it is completing before it, it's well and good for us. If it is crossing that time, so your investment will increase, either in terms of money, material, whatever it may be. So you can see constructions. So people thought that this home will be constructed by 2020, but because of this pandemic, so the construction has been stopped, because of which they have to pay the rent, they have to, so n number of issues are coming. So if the project becomes extended, you will try to lose the grip on, you will try to lose many number of your resources in terms of time, money or cost, okay. The activity which does not lie on the critical path, so you have taken a path which is the longest path, which is the shortest time consuming, then that if any event is not present on that activity, then it is called as non-critical activity. Means even if it happens or not happens, we do not bother much, okay. So these non-critical activities may have some slack time, means some time which is not needed, which is because of which there is some delay happening. The slack is the amount of time in which the start of an activity may be delayed, For example, your construction is currently going, suddenly there is a strike is called off, because of which your material will not be able to reach your industry, because of which your construction has to be stopped, okay, without affecting the overall completion. But whereas because of the presence of stock within your company, the whole completion times remain same, but you might have delayed the activity starting because of bringing the internal stock itself. This kind of timing is called defect is called a slack defect, okay. This, to reduce the overall project time, it would require more resources to reduce the time taken by the critical activities to complete. So this we will see in the next class, what is scheduling of activities, earliest time, latest time, how to identify this, how to draw a network analysis for a given problem, and how to identify the critical path for the particular problem, and how to draw this what is a toth path, how to identify the critical path. So that we will see. For example, if you see this network is having a number of paths. So we have identified that this path is a best path for the doing of this particular project, okay. So that you have to identify, that we will see in your next lecture, okay. So with this completion, we can able to complete your all 5 in ISMA. So go through your classes, and if you have any doubts, please let me know, either it is personally or you can even comment on the comment section. Thank you.